In this video, we take a detailed look at a 1940s wartime Marryat Scott in a deep level bunker. This bunker goes down 50 metres. It is an epic deep bunker, and this Marryat Scott is absolutely epic, but it's got some features a bit different to other lifts, so we're going to look at the features which are unusual before we do anything else. So let's just get on it. Now the switches are Soviet switches, so that means the lift's above your position has to come down. That means it's at your floor, so it stops. That means it's below your floor and goes up. Now, weird thing is, it's the top floor. So the top floor, even though it's top floor, it doesn't need a Soviet switch. It should just have a regular switch, but despite that, it's the top floor, but it's still using a Soviet switch, which is weird. Why do you use a Soviet switch for the top floor? There's 3 floors in this lift. This floor, ground floor, then about 50 metres deep is upper bunker, and just below it is lower bunker. So it's like long distance from ground to upper bunker, then lower bunker is just 3 metres below. So the middle floor, which is upper bunker, is the one that needs a Soviet switch. But for some reason, all the switches are Soviet switches. Now we've got the unlatcher there, and we've also got passive lockings on the inner door. So let's close this door and take a look at these features. Now to start up, we have pressed there. That's a feature because it was slightly modded. Ignore that, and obviously you inspect the door. So if we go up, now take a look at that switch there. The inner door locks on passive locking. So the inner door is passively locked, but the outer door is latch locked. It's locked with an unlatcher. So the inner door, as it's only passively locked, the inner door unlocks as it goes past each floor. But when the inner door is unlatched, so if I unlatch that inner door, it can still move. Safety's not broken by unlatching the inner door, because that is a passive lock on the inner door. So it can unlock when it reaches the floor, but doesn't break safety. But on this, that is proper lockings, not passive lockings. So if you press that, safety is fully broken, it can't move on the outer door. So proper lockings on the outer door, passive lockings on the inner door. Now we're going to go up slightly more. Now, what is this? This is the overrun switch. This is different to most lifts. When that goes up, it presses that, and notice that bar there and that pin. If the lift over travels, it lifts that, and if that lifts, that turns, and that bar there, see that bar? That comes out on over travel. That is the overrun switch. There's no regular overrun switches. The shaft switches are just the Soviet switches for precision. The overrun switch is on this bit of string.
So let's just say overrun, it might push up, and it pops out like that.
Now, we're going to take a look at something that you don't get nowadays. Something that should have been replaced, but is still here. Passive governor. Now, you've heard of passive door lockings, but something that shouldn't be in service today is a passive governor. This lift's actually rated as dumbwaiter only. They degraded the lift down to dumbwaiter only standards because, well, let's face it, it's really rusty and not up to passenger standards, but technically this is a dumbwaiter, so that's why it's got passive governor. How does the governor lock? It doesn't. Unlike a governor, this isn't the governor, it's just a wheel. In fact, there's no governor on the lift. So if the lift goes too fast, it won't stop it. It doesn't lock out. It cannot stop the lift overspeeding. All the passive governor does, well, it does nothing. It's just a wheel. If these main cables snap, so say the main cable snapped, the governor goes tensioned. So that side is the car side, that's the counterweight side, and that goes tensioned and locks up the safety of your lift and stops lift. So that protects against cable snap, but it's cable snap protection only. It does nothing else. The governor is entirely passive and will not stop overspeed. Nice to see it still here, just for a bit of history, since this is a dumbwaiter only. Now you've got there the unlatcher. That was not original, that was added in later, because obviously originally it was passive locking for both inner and outer, but as it's now proper lockings for outer, they added the unlatcher. So now we're going to take a look at a motor room before we go down in the lift. So let's go down. Now we're going to take a look at a motor room. So there's your car top. Now if we go down to a motor room, it was modded. It originally ran on DC.
This lift used to run on 660 volts DC. What a weird voltage for a lift. This lift must have been so custom built and so interesting. Sadly, it's been modernised now to 415 volt AC. But that original lift, that was unique to these bunkers. And the reason why the lift was 660 volts DC is because the backup supply from the bunker came directly fed from the third rail of the London Underground. How weird is that? And as back in those days you couldn't convert DC to AC that easily, that meant the primary AC supply had to be converted to DC, just that all the equipment all ran on DC. How weird and unusual.
they had to make the entire bunker DC using an arc rectifier, so the lift logic had to be DC. Since it was converted to AC, obviously they don't want to keep DC supply going, it's very custom. It'd be nice if they did, but yeah, they didn't keep the DC supply going, so they had to modernise the lift to AC. With an AC, relay logic is still almost exactly the same design as the original logic. The only difference is it's got a proper locking for the outer door, when originally the outer door was just passive. But apart from that, this logic is identical in design to the original logic, but using modern relays. Go! That's the lift moving! So, how does this lift logic work? Let's take a look and find out. We start off with the 3 phases coming in. 3 phases coming in, got the up and down main contactor, sets the direction of the motor, it sets the rotation, and MC, main contactor, and starts the lift motor, and there's your motor. So that is your main power side, simple and single speed. The rest of the diagram is the logic level side. Let's take a look at that. So going into the logic level, we've got fuses, phase test, make sure phase is the correct order. If those are all okay, it then goes on to the main part, the non-bypassable safety. Well, on this lift there is no bypassable safety because it doesn't have pre-doors. But if it did have pre-doors, this is the part that's non-bypassable. This is your major part of the safety. This is the emergency stop safety. So only if you over travel, shaft limit switches, car emergency stop switch, motor emergency stop switch, and the governor switch are all set and working. Can anything else happen? If any of those things don't work, nothing can happen. So those have to be present for the rest of the logic to run. Then the rest of the logic, it's got your latching floor buttons. Then you've got, there is your brake release, that releases the brake so the lift can run. Then this part here is the floor logic. The floor positioning logic here can only operate if the doors are shut. If the doors are open, the positioning section cannot run. So this here checks the doors are shut, but this does not check they're locked. It only checks they're shut. So if the doors are open, you can't latch a floor. You can't do a latching relay on the floor. If the doors are shut, you can do latching relay on the floor, and then this part happens. It then has to decide the direction. Floor 1, down. Floor 3, up. Floor 2, Soviet switch, and the Soviet switch decides if it's up or down. Quite simple. Then the dotted line's inspection. So the dotted line shows inspection up and inspection down. That's what runs if it's on inspection. Then, only once the doors are locked can it start. So if the doors are shut, you can set up the lift ready to depart. But only once the doors are locked will it actually depart and main contactor then activates. And that is how your lift logic works. Very simple. So, if we take a look at a lift logic, we can see where everything is. You've got your main contactors up and down. They activate once the lift's all set up with the floor buttons ready to go. The main contactor only works when the doors are locked. There's main contactor. There you've got your floor relays. TR is your main safety relay. And so now we're going to go down in the lift and we're going to go downstairs and take a look. Notice the doors open opposite directions. That is very weird. Car lighting has never worked. There's a Marryat Scott lift, but the sign's gone. So now we're going to go down. Inside the lift then, obviously, we're going to surf it, obviously, after that. And here we go. See, this lift is very, very rusty. And this is the longest single speed lift I've ever been in. 0.66 metres a second single speed going down 50 metres. It takes a long time. Now, we can't open the inner door because it's got passive locking. So it will not open. But when we come to emergency doors in the shaft, these little emergency doors, these aren't floors, these are just emergency doors. You can now open it when you pass one of these emergency floors. There you go. We can now open it because we've just passed an emergency floor, and then you've got your passive lockings there. See, the door unlocks it, passes one of these little floors. Now we can carry down on our journey down the lift shaft to lower bunker. Those little doors partway down the shaft, partly for regulation, that lifts have to have regular doors, and those are just to get people out of the lift, so if the lift ever gets stuck, you've got extra access points. Those extra shaft doors are not floors, they're not floors in the logic. Buttons sadly been replaced, and we're now coming up to the lower set of emergency doors. There's 2 sets of emergency doors on both the top and bottom, so 4 emergency doors in total. That's because of a double helix staircase. Got a double helix staircase out there. And you'll see the passive locking on the inner door actually unlocked as it passed that floor, but a lift did not stop because that inner door is only passively locked compared to the outer doors, which are actually locked. It's a nice rusty lift. Oh, that's not a good sound it's making, eh? And here we are at upper bunker. And now we go down to lower bunker. Here we are, that is lower bunker. Now we're going to go up to upper bunker. And we can see the DC supply. It used to run the lift. So here we are on upper bunker. So this is upper bunker level. There's your buttons. Nice look up the shaft. Now before we surf the lift, I just want to show what the DC supply looks like. DC supply is in here and looks very interesting. It's Art Rectifier, absolute classic. Look at that, Art Rectifier. Very, very nice. So the DC supply worked by 3-phase goes in there, through your transformer, comes out in there, goes into your Art Rectifier, goes in outside, DC comes out the bottom, I think this is what DC comes out, and that goes to all your DC equipment, as well as having circuits like for the lift and everything else there. You've also got these lovely resistor starts, so very, very interesting. That's your DC supply to a motor. Obviously that's not in use anymore because it's been changed to AC. Got resistor starts for a fan, they clunk round, and as they clunk round they start up that big DC fan over there. Very, very interesting DC supply. Sadly not in use, it's now obviously been converted to AC. So now, I think we're ready to surf the lift. Yes, we are. Right, down goes the lift, now we can get on top. And now, we can get on top of the lift and surf it. Is it lift surfing time? Yes, it is. Let's go and surf it. Oh, that's a good view there. It's a very, very long lift shaft. We are 50 metres deep underground. This is a really good lift ride. Like, this is one of the best single speed lift. Going 50 metres, it takes a long, long time at its speed. It's so nice to see a 1940s lift in a big tool application like this. It just, oh, this lift feels good. This lift feels so good. There it goes through your shaft floors, just there. Ooh, that fell off its track. Yeah, this lift's not in good condition. It's licensed to dumb waiter only. It's really not in good condition. In fact, it just fell off its track. That is bad. That is bad. You got your doors there. That's your shaft doors for doing a rescue. And now we're coming up to the top floor. Ground floor. We are back up at ground floor. Let's hope I've got enough battery on this phone to get back down again. Is this hope? Phone, don't run out of battery. Phone? Oh, that's better. Let's hope that track doesn't fall off halfway down the shaft again. That shoe, look how bad the shoe is. It keeps falling off the track. It's about here when it happens, I think. There's your counterweight. Yeah, it didn't do it on the way down, just on the way up it happens. Oh, there, see it? Oh. Not good, am I? Come down to this part now. Now arriving back down at upper and lower bunker levels. The other shoe's in slightly better condition than that one. And here we are back at upper bunker. So lift stopped at lower bunker, I'm on upper bunker. And that is surfing a vintage lift. So, here's the bunker. If you want to see a tour of a bunker, make sure you check out my video of it. This bunker is absolutely epic.
Hey Ben, I didn't hear you last time.
Hello Jordan, where's your location?
We're on the basement level and Glenn's currently flying his drone backwards and forwards in the corridors of the basement level.
Okay, I'm coming over to you. So, visual wartime beds here in the bunker. Gotta do an overnight challenge down here, just got to. This is too good an opportunity with a working lift and everything. This is brilliant. And just quickly, so you can see the original buttons, here is the other lift in the bunker. It's obviously 2 lifts in the bunker. And that is your original button. So for purposes of the video, on the other lift, since there's 2 lifts here, the other one's got original buttons. So just so we can all see what the original buttons will look like, this is the original buttons. They look really, really nice. And that is the end of the video.